All right, here's how we do the second part of the M&M sheet, and this is in case you need help or in case you're absent, and this is for period 1. So here we go. I've already got my copy of the sheet open, and this will be posted on Google Classroom for you, and when you open it up, it'll look like this. There is also a handout posted on Google Classroom that leads you right through it, and the formulas that we're going to be putting in are all documented right here on the handout. So if you get stuck, you can use the handout to help you, and you can use this video to help you. So here's the first thing we're going to do. We're answering questions like, when you buy a bag of M&Ms, how many do you get, and is it always the same? Is there more of one color than there is another color? What usually happens with color? So we're going to find out. So let's start right up here at the top with Aomides M&Ms. He's the first one on the list, and by the way, if somebody's name does not appear on the list, it's because they weren't there for doing the M&Ms. So we're going to start with Aomidi up here on row number 8, and I'm just going to select his all of his numbers of M&Ms from red down to brown. The next step will be just to calculate a sum. We just want to add those up and see how many Aomidi had. So I'll hit sum and I'll press enter, and it's going to do the suggested autofill for me right here, which is good, or you could use the duplication handle to duplicate it down. But there we go. Now we're finding out that usually, in most cases, if you buy a bag of M&Ms, it's in the 50s, right? You can tell now. Look at it. Look at that list. Most of them are in the 50s. Now there is, what's that, Peyton? Peyton's bag that we worked on had 61. I'll tell you, that's really unusual. That's awfully high. And also, Jazaria's bag was a little unusual as well, because usually you have at least 50, and so most of the times it's like more like 55 or so. But Jazaria only had 48, and who was our highest? It looks like Chloe had 58, and also Maya had 58. So those look like, well, no, and we had that 60, that 61 for Peyton. So those are the higher ones, and Jazaria had the lowest of the bunch. Sorry about that, Jazaria. All right, now we got some other calculations we're going to make here. Where it says color total down here on, it's on row 26, and I just clicked on B26, and it says color total. So what we're going to do is add up all of the reds, all the red M&Ms. Well, all right, so the red M&Ms start up here with Aomidi, and they stretch all the way down to Caleb, right? So we're going to click up here with this 8 and drag down here to this 16, and then we're just going to calculate a sum. Now that sometimes it jumps around, it looks like it's going to put it in a weird place, but I don't think it will. I'm going to go ahead and press enter. Now this time it wants to fill down, but we do not want that. No, 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 no. We don't want it to fill down, so I'm going to hit the X, and what we're going to do is we want to click right here where it says 187. It has added up all the red M&Ms. Grab the duplication handle and drag it sideways, and there we go. All right, so now if we were to ask the question, is there a most common color? Well, for our first hour class, we have an answer, right? It's right here. It's yellow. We had more yellows than anything else, and if you look at the bags of M&Ms, that was true not on every bag, but in most bags. In most of them, there were more yellows than any other color. And if you take all of them and add them up, then yep, most yellows, right? That was the most common color. So there it is. That's an answer to a question. All right. Now we're going to go to this next calculation, which is for averages. This is going to be what was the average number of red M&Ms? Well, all right, this is another one of those times when we're going to have to write the formula ourselves. We can't just like drag down here and pick average off of the list. So here it goes. It's on the handout, and here it goes. I'm going to say equals. You always do that. And it's kind of trying to help me out here, but I'm going to go ahead and type it. Average, parenthesis. And if you just want to make sure, Aomides red M&Ms are up here at B8. So I'm going to say B8, and then I'm going to put that colon in there. It has to be a colon. And again, it's trying to help me out here. I'm going to keep typing, but Google Sheets is trying to help me out. So it's looking here and thinking maybe you want to get an average all the way down to B25. Well, I do, that's correct. So I'll just type B25 in there and I'll close my parentheses. So right there is my average calculation, equals average B8 colon B25, press enter. Now here's something that happened. There's a lot of decimal places here. So you can come up here to, there's a button on the toolbar. There's some buttons up here that say decrease decimal place and increase. Well, we don't want to increase it because that would give us more decimals. But I'm going to decrease it a little bit. I'm just going to come up here to this button and bump that down some so I don't quite have that many decimal places. All right, that's better. Now I'm going to grab the duplication handle and I'm going to duplicate it over, and there we go. All right, so now I know the average number of red and the average number of green and the average number of blue. And again, right here on the average, almost 11 yellow M&Ms. And on the average, in a bag of M&Ms, you get 55 point, well, rounded up, right? 56 M&Ms is kind of the average if you round it up. All right, now let's do this calculation. This is for what was the smallest number or the lowest number of red M&Ms. I'll show you how to do this. This is another trick that the computer knows, and you don't have, I mean, it's easy to find. I think it's 4 right there. Brennan only had 4 red M&Ms. But here's how we're going to do that. Don't just type a 4. Here's how we're going to do it. We're going to say equals and the code for this. It's like a function. It's MIN. It means minimum. It's going to tell the computer to go look at all the red M&Ms and find the smallest. All right, so we'll go parenthesis, and it's going to be B8 colon B25, close parenthesis. Now remember, all of these formulas are on this handout. It tells you right on the handout what to do in case you get confused. Or you could pause this video and go do it and then come back and resume the video. All right, I'm going to press enter right there, and it found that 4 for Brennan. And now I'm going to grab the duplication handle and take it all the way across, and there we go. All right, so we have our lowest number for each one. Somebody only had 2 blue M&Ms. That was Michaela. All right, now we're going to do a similar thing, except it's going to be for the highest, right? The highest number. And we're going to just start with the red M&Ms. What was the highest number of red? And again, I think it's not hard to find. It looks like Gage had 17. But let's do it. Let's make the computer do it. Let's make the computer do the work. Here's how. I'm going to hit an equal sign. It's kind of like a calculation. And I'm going to say MAX, which stands for maximum, right? I'll just say MAX, parenthesis, B8 colon B25, close parenthesis. And so now the computer is going to look at all of those red M&Ms and find the biggest number and tell me what it is. So I'll press enter right there, and 17 is correct. That was Gage Gilmer. And then I'm going to duplicate that across. And again, we're seeing the highest number of green was 12, and the highest number of blue was 13, and so on, all the way down. All right, the biggest package of M&Ms was 61, and that was Peyton's package. Now we're going to do a range, and that's going to be the highest number minus the lowest number. Look right above. I'm in cell B30. And so this is going to be, it's going to be 17 minus 4 for the reds, but don't type 17 minus 4. It's going to be a subtraction problem. We've done these before on other assignments. So it's going to look like this. Equals, and that 17 is sitting at B29, and then I'm going to subtract B28, the one right above it. So it's B29 minus B28. And I will press enter. And the difference there is 13, of course. That was not hard math. And that's not the point. The point is not that it's hard math, but I want you to make the computer do the math. Now I'm going to drag that across, and we have all of our calculations are made. Yay. Now the only other thing you have to do on this, and you knew it was coming, you got to pretty it up a little bit. And I'm not going to be picky about that. I'm never picky about that. But you're going to have to come along here and kind of pretty it up a little bit. Do something with borders. Do something with fills. Do something with fonts. do whatever it is that kind of floats your boat there. I might take these names right here and right justify them and bring them over like that. I might like that look a little bit better. All right, so there it is. I've done everything, and one of the things I'm going to do is I'm going to check I want to see the formulas in there. I have a keystroke I can do that shows me all of the formulas. See that? And so if you did this assignment correctly, like I just showed and like the handout has, and yeah, I'll be able to see all of your formulas in there. And it should be, formatted a little bit so it looks nice, and that is it. That's the assignment.